Oh my gosh.
What?
There's 39 questions.
Yep.
Anyways. All right, let's go. Okay, deciding.
And type in the letter. Okay, that's good. Let's see. So, an article in the journal. Okay, it says one set of data. So we can eliminate the two C and D.
Right?
Oh, hold on. One set of data compared the educational levels of people who who managed to drive successful startup companies in the United States and Korea. Okay, so these are kind of categorical because it's saying that the people in each of these groups were able to start up a different things.
Different company?
Yeah, I was thinking it maybe H because hold on. We want to determine if the educational level companies is independent of the countries they are from. So you're kind of comparing the educational this I think it's H for the chi-squared test for independence because we're trying to determine if the educational level has and is
It has an impact to the being able to
country
speak.
that they're from.
Yeah. Okay. I will agree with you on that one. H.
And also there's kind of like too many groups to do the other tests.
Because, yeah, the other test I was just thinking of was just the independent simple T test, but
Yeah.
that one makes more sense. The human resource manager reported data amount to.
We have two different groups, the 40-year-olds and the younger. Let's I think this is going to be a categorical test, so it's going to be either F, G, or H, because it's kind of saying the number of people who fit into this category or that category.
Right.
And I'm thinking it's G because there's tests for two proportions. Because in testing for two proportions, you're comparing like the pH to another pH, and you have like the X1 divided by N1. So you have your first group of people who are younger than 40 that were terminated, and you're comparing that to the number of people that were terminated to those who were over 40.
Right.
Let's see, but if you have any other ideas, that
No, that one makes sense too, Shelby. I'm just thinking like, because it won't be the one simple one, so those are excluded. Like, they'll be are out. It won't be the pair simple test, right? Because, like you said, it's two different groups.
Mm-hmm.
So you said the one was the test of the two proportion? Ow. Ow. Is that what you said?
Yeah.
G. Yeah, that one makes the most sense too. Do we
Okay.
capitalize the letter or do you just type it in?
I think it's lowercase because if you look up in front of it, it says You may use the hypothesis test more than once, more than once, or not at all. In the answer box, type in the letter A, B, C, E, C, T.
Okay, because yeah, okay, so just lowercase.
Yeah.
Okay, number 4. The survey was conducted of a group state line random. Random. Which one's the random one?
Well, a lot of them can be the random one. I think
But
you're thinking of the simple random testing, which is
uh-huh.
a type of test, like to get different proportions from.
Hmm?
Like it's like a method of collecting data, but this is we're trying to test to see what it is. Let's see, what did I put? Well, I don't think it's E
Yeah. I don't think it's E either.
or H. Mm.
We're 248 were classified as heavy players and of these one to do a mill.
We want to determine the proportion. Oh, and then it has that word proportion in it, which
Mhm.
means we can cross out A through E.
Right, so it's gonna be the test 1 and test 2.
Yeah. I think it's going to be
It'll be F test 1, right?
wait,
Wait, hold on.
I mean
Philip.
F. Yeah, F.
Yeah, because you're just testing the mill, right?
Yeah, you're testing just the one. Okay, the student project is to compare the effectiveness of two different combination locks. One of the locks turns clockwise first, and then the other lock turns counterclockwise first. They asked 25 students to participate in this study. Each student was given a combination to each lock and asked to open the locks. The time it took them to open each lock was recorded. They determined if one of the locks was easier to open. Hmm. So pretty much you're trying to compare two different things. So you're going to have like,
Hmm.
but you're trying to determine the difference in time, right? Like to
Yeah,
see,
the recording.
yeah, you're
We're recording
wanting
the time.
which time's faster or better. I think it might be C.
The pair simple t-test.
Mm-hmm.
Why?
Let's see. I don't think it's categorical, this test and this test. And
Hmm.
if and let's see. And you have two different things, but you have the commonality of the one person. So the only thing that's so there's
But I don't think it would be that one because the pair simple t-test
yeah,
is,
and that's what I'm thinking too. I'm like,
is
wait,
the average of the average between both of them.
it's the average.
Hmm.
Hmm. Maybe the independent sample.
Let's see. Let's look the definition of that.
Because I
Okay, the independent simple t-test compares the mean of two independent groups in order to determine.
Or to determine what?
To determine whether there is statistical evidence that the associated population means are slightly different, which makes sense
Which makes sense.
because there's two different groups.
Yeah.
So I would agree with that definition.
Let's see. Yeah, so we're gonna do what are we doing again?
D. Independent.
Be independent. Okay. Deciding on the confidence interval to use. So oh, let's see. I think maybe B.
To this case, the bank component that is six properties that both of them recent.
Maybe.
Let's see. Definition of that one. Yeah.
B?
B as in boy.
Yeah.
Okay. I thought I picked that one. What's she drawn?
I think this one's gonna be either E or F. Based off of kind of it has like
Right.
it's kind of categorical.
Yeah.
Like,
Um.
are you satisfied with this or are you not?
Yeah. Basically, it's like straightforward. I'll go with F.
F?
F as in Frank,
Yeah, why F?
because both of the majors are two different majors.
Wait a second, because it says in the Wall Street Article Journal, it says the percentage of psychology majors that were satisfied with their career path was reported. The same data. Oh, I didn't even read that for the
Yeah.
accounting majors.
Yeah.
Yeah, so it would be F.
Okay. Ooh, double stuffed oil sounds really good right now. Shall we?
Yeah,
Oh,
yeah.
okay.
Sorry, it's just like just kind of thinking to myself, why would you even bother to waste time doing this? Shove it in your mouth. Enjoy. You and your friends. Take a sample at 55, double stuff, and measure each filling. Construct a confidence interval.
Okay, so you're just measuring one of them.
Mm-hmm. Let's see. Maybe D? Because you're comparing it to the regular filling.
Are you? I'm not
You need to
sure.
construct a confidence interval in order to compare to the filling. Oh, maybe just the one can.
So you compare it to the other regular Oreo, double stuffed to regular Oreo.
Yeah, but let's see. It only says you take a sample of 55 double stuff, and it doesn't say anything about the regular amount.
Yeah.
But it's this is a weird phrased question. Measure the filling you need amount of double stuff in order to compare it to the filling amount in a regular Oreo, which
It's not the one.
because it might just be, from what I'm seeing, it's just only taking like just the double stuffs and measuring them and
Yeah,
creating that
it's like measuring the 55 stuff Oreo to one measurement of the regular Oreo.
Yeah, exactly.
So which confidence interval would be most appropriate?
I don't think it's E or F,
No, I don't think that either.
and I don't think it's A.
I don't think it's C because it's not a pair simple, is it?
No, I wouldn't think so either.
So is it gonna be
B,
independent sim D or B?
D or B. I'm thinking B more though.
Why?
Well, since we only have the one item that we're really testing. Let me just see something. Uh,
Let's see what's the definition of the T interval. Mhm.
see. Uh,
I think it might be D though.
D.
hmm
Yeah, I'm not. Why do you think it's D?
Because the one simple T is just measuring just about one specific thing, not measuring it, comparing it with a different one. Like for example, like the amount of Americans that eat meat per year, and they're only measuring like the average amount
Mm-hmm.
just for one specific topic, I believe, if I'm
Yeah.
understanding.
So B or D?
Why'd you be like E or F?
And I was like, well,
uh,
well, because it's more of like the amount that's present
right,
rather than a category.
right. Um, um,
Crunch.
mm,
I think it's B because we really don't have a second category that we compare it to.
okay, let's go with B. Let's go with B.
Yeah.
Uh, you're more smarter with this than I am. I'm more just
I want to keel over and die too on this.
yeah. Too bad we got 30 more questions to go.
Woo! Okay. See, which of the following best defines the notion of significance level of the hypothesis test?
Of the significance level of the hypothesis test,
Yeah.
isn't the probability of rejecting the hypothesis whether it's true or not?
I was thinking that the probability of, I was thinking it was the probability of rejecting the null. Whether it's true or not. Is that what you said?
Yeah.
Okay. Yeah, that's what I was thinking too.
Yeah. A?
Yeah.
Yeah.
And then while number 10, I was thinking the probability of observing a sample statistic more extreme than at one actually obtained, assuming that the null is true.
Right. And this was 95% of mean to get you totally percent instead of like we are 95%.
95% of all 95%. I'm thinking it's 95% of all 95% confidence intervals are actually contained.
In the true mean.
The true mean.
Yeah. D. That's what I thought too.
Okay, 12.
Ooh, getting tired already. Good. Your simple addition.
Mean of the distribution of this.
What is the mean?
Mm-hmm. I'm thinking it's 0.3.
0.3, right?
Yeah,
Yeah.
because p hat equals p. The mean of p hat equals p. See the standard deviation. That's going to take a little bit of time.
It's cold.
Indeed, it is.
Okay. Anyway, sorry. The standard deviation of the simple proportion.
Did you get an answer?
I have to go back to my formulas. I forgot my formula.
Mm.
Did you get your formula?
Yeah. Well, I got the answer. As
Did you get 0.458?
0.046.
There it is. Come on. Ooh, wrong one. Okay. Got it.
What'd you get?
The 0.046.
Okay, cool. What is the probability that your random sample of adults of 100 will have a sample proportion less than 0.25?
Good question. Is that like find a p value? No. How would you find that, Shelby?
I'm trying to figure that out. P-value. That's what I'm thinking, or it could be in the probability applet.
Mm-hmm.
Be the and I have a score of, let's see, 1 point. Let's see, what did you get for your thing? I got 0.124.
Hold on, still calculating it.
Mm-hmm.
Are you using SPS?
Yeah.
Okay.
And I use the z-score.
Right. To find the
Yeah.
okay. Okay, yeah, I got the same thing. 0.124.
Yep.
Okay. Oh man, 15 to 19. What the heck? Hmm. Dang, we had to do this long equation again. Why? I need more paper. Yeah. Sweet, sweet. Create a 95% interval. Mm-hmm. Ah, so shall we?
Yeah.
How do you find a p hat again? Just the regular p hat? Isn't it just a one?
X divided by n.
Right, so it'd be one. It'd be 579 divided by 1563, right?
Yeah. No, no, look at this guy.
Why did they do this to us?
Oh, hold on. So you have two groups, remember?
Right?
So you have your 156.3.
156.3.
Yeah.
Oh yeah.
That's going to 61 divided by the 156.3.
Uh-huh.
And then your other group is going to be 15 divided by 579.
Right, but then how do you find P one?
Oh, P?
Yeah.
Let's
How do you find the P hat?
just P hat by itself.
Yeah.
Let's think. Because there's the formula for that. See. Think this is going to be a bright spot. It's going to be x1 plus x2 divided by n1 plus n2.
Oh, okay. Okay, let's see if we have the same number. X1 is 60. Oops. Crap, dang it. I already messed up. 15. 15 is for 15. I'm doing this wrong.
We were victims of the night. Chemical, physical, kryptonite.
X1 plus X2 divided by N1. Okay, so your p-value, did you get 28?
28 for the two of them combined.
Not bad. For the p-hat, did you get 28.184? Perhaps?
Hold on. So 70. What did you get again?
28.184 for
I
the.
got point oh.
No, I mean that's just the p-value. P-hat.
Oh, the p hat. Yeah. What was the other value? What were you looking for? Sorry,
Just the p-hat.
just the p hat. That's what I got for p hat though.
What'd you get?
0.035.
Let me go back and. Oh. Sorry, Shelby.
What did you do?
I switched the numbers.
You switched the numbers. You had n on top, and
Yeah, that's what I did wrong.
so I was just kind of confused about that. I was just like, how did he get that?
Yeah. But let me. Okay, I got 0.0352. Okay. We're all good now, right?
You gets now.
Should be easy now, hopefully.
With me now. I'm gonna get on.
7.032.
But I don't think we needed to solve for just p hat by itself.
You don't think so?
Nope.
Okay, got an answer. Okay, what'd you get?
My answer I got was negative 0.003 and then
0.029?
0.029.
Yes.
That's what you got? Excellent.
Yeah.
Form a hypothesis test to see if it's true. I put that it was the null hypothesis is P1 is equal to P2, and while the alternative hypothesis is P1 is not equal to P2.
Yep. You smart, girl. You're smart. What is the value of your test statistic? Is that just a z value?
Yeah.
Okay. I haven't found a p-value.
What did you get for your test statistic? Or
It's the positive one. 1.458.
1.458, and then we can put that into the normal probability applet.
Is that what you got too for your test statistic?
Yeah, 1.458. It's not equal, so it's going to have two tails.
Right.
So I got 0.145 for my p-value.
I'm still plugging it in.
Oh.
You work fast. I like it though. I like it.
Well, okay, so pretty much all these questions,
it's all flowed together.
It's the same as the individual preparation.
Right.
And I did the individual preparation. So I have all of it done.
Yeah, the individual preparation for me is just it just opens up to the thing.
Yeah.
The statistic flowchart and stuff, and the please review for exam, that thing that you click on.
Yeah. Well, it opens up to this, like, hold on.
The book?
It opens up to that document, not
Yeah.
the document, but the web page.
Right.
And if you go down on that web page, the
all of it is the same.
The review for the exam 3.
Yeah.
If you go down to the review questions,
Uh-huh.
they're the exact same.
Yeah.
So I just did them, and I was just like, okay. That's what I did last time too. So I was just like waiting for you guys, and I was just like, oh, this is fun. And sometimes I had to change my answers and I was like, oh, that's how you do it.
Okay. Okay, sorry. Number 19. This portion, speech dozens is different from the true proportion of the people who experience dizziness while not. Oh.
Well, our significance level is
1.1458.
So we can't reject it.
No. So yeah. No, I failed to reject.
So there's not any difference. So now I failed to reject. Okay, the next one.
I failed to reject. What?
This one you better pull up something, like one of those file things.
Okay. Wait. 19 no, I failed to reject no hypothesis, right?
Yeah.
Yeah.
Next one's the chi test.
Oh.
Chi
test flow chart. Okay, did you get the 0.658?
0.658?
Yeah. Or did I put too much number in? Columns 1, 2, 3, 4 rows.
Hold on, let me just double check.
Hold on. I think I know what I did wrong with this one.
Because I got I got 6.58.
Yeah, that's what I got.
Oh, you got that? I thought you said 0.658.
No, 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 no. Did I?
It sounded like it, so I was just like, I don't know.
Huh. Because I kept doing it over and over. I was like, yeah, I can get the same thing though.
Yeah,
Yeah.
it's so weird like that.
Calculate the p-value for the hypothesis. I hate finding the p-value.
Mm-hmm. I got 0.087.
I'm still typing it into Excel really quick. Okay. 0.087.
Yeah.
Okay. Should you reject the null hypothesis or not? Well, our test is 6 to 6.5. Hey, should we reject it?
Nope.
No, because the p-value is greater than 0.05. Right?
Yep.
Okay, what do you conclude? We have to fix it. Evidence. Did you put A? I'm thinking is we have significant evidence to say that being a morning or evening person is independent on age.
Um.
Or it's not. Hold on. Let me read the state. Let me read the. Oh, it's not.
Mm-hmm.
Did you put that?
Hold on. See, conclude. We have sufficient evidence to say that being a morning person is independent of age. We have insufficient evidence to say that being a morning or evening person is
Not.
not independent on age.
Uh huh.
Is that what you put?
Uh huh.
Excellent. That's what I put too.
Oh no, it froze. Oh, never mind. I'm back alive. Okay.
Alive.
I'm alive. Use the file information.
So I think this is a the one proportion test.
Uh-huh. It is a one proportion.
Yeah. I kind of just like to say what test it is, so you know. Like, oh, oops, belongs to this. Da, da, da.
You get the 0.0195?
Point. No.
Did I use? Which number did you use?
Let's see. I might have done it wrong, but let's see.
No, I think I had done it wrong.
I said okay, so our n value is 200,
Right?
and then 50 would be our x value, and then your p value is going to be 0.2.
0.2. Is it?
Because your p value and your p hat are going to be different.
Oh yeah. It is 0.2.
And then I don't get the hold on. Let's see. So what'd you get? No.
The 0.190.
Yeah, that's what I got.
Okay.
And 310.
Yeah. Suppose you study. So 0.2.
Oh, this is. I totally forgot about this, but I think I remember it now. Estimator. Okay, so our margin. We're trying to find the n value. We have a margin.
What's the margin? Margin is
2%, so
0.2 then.
0.2. And we have a 95% confidence interval.
Mm-hmm.
And then our p value. Let's see. Let's see. Okay, so 0.196
0.196
divided by 0.02
times 0.02.
squared. Hold on. Delete. Let's try that again. 0.196 divided by 0.02 squared.
What? Okay, I got n equal 2401.
Hold on, I'm getting there. Because I did this one wrong, I think. Because I totally forgot about that you can find the n value this way. So it's 0.2 times 0.8. So you got 1,537.
No, I got 2401.
Okay, let's see what I did
What's
wrong.
it? So your what do we call it? Your z or your p, what is your z or whatever is 1.96, right?
Yeah,
And then your m, the margin is 0.02.
0.02, and you divide that.
Right, so you do 1.96 divided by 2 times 0.02, and then you square root that.
But don't you
I
square
mean,
the
square,
values of z and m?
z and m.
Z and m squared times p times 1 minus p. Because I can show you.
You got 1537.
Because if you look right here, there.
What?
Well, if you look right here, it says n equals z squared divided by m squared times p times 1 minus p.
Because I did the one below that, where p is a prior estimate of p. If no prior estimate is available, the formula is z over 2m.
But we do have the part estimate.
Oh,
Because that's 0.2, right?
I thought 0.2 was the margin of error.
No. The margin of error is 0.02.
Oh,
Because it's
I completely just missed that part. Makes sense now, Shelby.
yeah. No, I was like, wait a second.
I completely just missed that part. I was like, Shelby, what are you talking about? Okay, got it. So yes, it is 15,337. My bad, girl, my bad.
No, it's fine.
Okay.
Okay, suppose you want to blah blah blah. 26. I think it's C.
C. The one with a null hypothesis equals 0.2 times age. I mean, well, point equal 0.2, and the alternative hypothesis is greater than 0.2.
Yeah.
Okay. How many measurement must you have in order to assume that P is no more reductive? Isn't it P is greater than, I mean, N is greater than 5?
That's for a t-test. For the t-test, you have to have at least 5 as a value. But for all the other categorical tests, they're related to 10. And you have to compare it to 10 and see where it is on that. And then for the other tests, the quantitative tests, you do 30. So it's NP.
NP. Sorry?
Because this is a let's see, categorical. Yeah, so hold on. If you look at the study guide, or I can just
No, I
screenshot.
see it. I have the study guide open.
Yeah. Just lesson 17.
Right?
And if you look at the third bullet point down,
Okay.
do you see the what it says? Requirements for the confidence interval.
Okay.
Testing of one proportion, which is what we're doing. Okay, so test statistic.
Find the test statistics is a C-score. You already got it, right?
Yeah.
Okay. I was like, she's waiting for me. Is it 1.768?
Yep, that's what I got.
Awesome. And the p-value, you already got that too. Okay, did you get the 0.077? Or did I do that wrong?
No, I got 0.039.
Why?
Let me type it in. Let me see what again. C so negative 1 point. What was our C score again?
7.768.
Okay. Okay, I see what you. Okay, so if we go back up to our we're only measuring for one tail, correct?
Right?
What you have is set up for 2 tails.
Oh, that makes sense. I'm rereading the question too. And yeah, it's only for one tail.
Yeah, so then you should get 0.039.
Yep. And in this, since it's not greater than 0.05, it is rejected.
Yay! We finally get a reject one.
For real. And so it says, yes, I reject.
Yes, I rejected it. And it felt so good.
Okay, sorry. Oh, 8 more.
And all these are going back.
Oh man, I don't remember.
Last unit. It like took me a second when I first saw it. I was just like, what? What is this doing here?
The lower box and upper box, I remember this. Man. Okay. Current environment split plot of 100. What'd you get, Shelby?
For 31,
Yeah.
I got 0.282 for my lower and then 0.293.
I'm just off a little bit on the higher.
What'd you get?
The higher I got 0.287, but I think I might have just added wrong. You said so. Okay, so you said 0.293, right?
Yeah.
Okay. Yeah, I added that number wrong. Okay, anyways. Calculate the degree of freedom. Is this for what question is this going all the way through? 31 to 34?
Yeah.
Degree of freedom is the column that is no, that's not the degree of freedom. My mind's going blank. Shelby, Keith, I don't remember trying to find the formula for the degree of freedom, but how do you do this again?
Degree of freedom, n-1.
Right. So
So
that's not fine,
99.
right?
Yeah.
And then the and then the t-score. What'd you get for the t-score?
I got negative 2.803.
Okay, that's what I got too, but I was like, is that too big?
And I got 0.006 for my p-value.
It's a two-tail, right?
Yeah.
Okay, that's what I got too.
Okay, so based on these results, what can we conclude? So we can say that we have sufficient evidence to say that the true mean is different from 0.95.
0.295.
Yeah, I totally said that. I really did.
I was
In my
like,
mind.
the number.
Just dropping a couple numbers here and there, no biggie.
One number doesn't change anything, does it?
No, not at all.
Okay,
Especially
go
the first number. Let's see. The next little thingamajigger, it's the AM heights.
The new score value will record in the morning again. You want to determine the children. Open the A/PM height.
7, 9. And I think since they're going to be two different heights, I'm trying to think.
Please open. Don't do this with me again.
What do you think they're going to be paired t-test or a two-sample t-test?
It's too simple. Wait, hold on. Let me read the question again. Don't take my word yet.
Because I think it might be paired.
You need to measure and record the morning again. You want to determine the children. Yeah, I think we'll be paired too, Shelby. Shelby, that's a problem.
What's the problem?
Like, for some reason, it won't open the file no more.
No more?
Yes, no more. I don't know why. I was able to open it today. What the heck? Don't do this to me.
Don't do this to me. C AM PM.
Because I see it. I'm opening it. But it just. Huh. Okay, now it's real. Okay, now it's opening.
Sorry, you froze on me, so I don't know what you said.
Sorry. It was just. Nothing. Okay, okay. Got it. Okay, testing the interval, 95% interval. Lower bound.
What'd you get for your lower bound?
I got a low number.
How low?
0.3. 0.3?
Ooh, I got 0.8. I mean 8 point something.
You got 8? The heck?
Now let me try this again.
No, let me try this again. You're usually right on this. Let me try this again.
I don't know, maybe not. Let's see.
Pretty sure you're right.
Well, if we go off the assumption that I'm always right, then I'm bound to get it wrong at some point.
You want to do the statistic thing again, Shelby?
No, thank you. No, no,
You can
no,
calculate the statistic of this if you want to.
no. Don't be mean.
Hmm.
See.
Okay.
Yeah.
Did you get 8.456? Yeah, not 56, 57? Around that.
Hold on. It's just 8.728.
For your lower bound?
Yeah. Let me just double check that again. Let's see. Yeah, 8.728. Let's see.
And then for your upper bound, did you get 10.688?
10.455.
Okay. I got two. That freak.
And then what did you get for your test statistic?
Did you get negative 2.038?
That sounds better than mine because I got 22.
22?
Yeah, I did something wrong.
What did you use?
Oh, you know what? That's my null. What's the null hypothesis supposed to equal?
Sorry, the null hypothesis what?
Oh no, the null hypothesis. Determine you want to see if the child's taller in the morning than the evening. In school. Mm. What'd you get? What was your value again?
Negative 2.038.
038. Yeah, I think that's right. 40. And then what'd you get for your p-value?
This is a two-tail?
What?
This is a two-tail, right?
See. We want to see if no, it's going to be one tail because we want to see if the children test the theory. We want to determine if the children are taller in the morning than the evening, not if they're different.
Yeah. I got, for my p-value then, I got 0.024.
0.04.
What'd you get?
Let's see. Well, I got a weirdo p-score and I can't figure out how to change that, so I had 0, so I think you're right with yours. 0.024. And then yes, we reject the null.
Okay.
And then we can submit.
Okay. I'm submitting.
Woo!
Oh, we got a 78. Oh my gosh.
Wait, you got a 78?
Yeah?
I got an 83.
How'd you get an 83?
I don't know. Okay, so we missed 5 and 6.
Correct. 9? I missed 9.
I missed 9 too.
Did you miss 14?
14. Let me go down. Yeah, I missed 14.
Then I miss also 27.
27. I didn't miss 27.
Oh.
What'd you put for 27?
I put D.
Oh, I put C.
C, huh? I knew it. I misclicked on that. What the heck?
Yeah.
And then I missed 32 and 33.
You missed 32?
Yeah.
I got that right.
Degree of freedom is 99, right?
Yes.
And then for the T score, you got negative 2.083.
Negative 2.803.
Ah, I put 0.83. But I wrote it down right here too, saying negative 2.803.
And then, let's see. I completely missed 35, 36, and 38.
Yeah. Well, that sucks.
Oh, thanks. Well, we're done.
Yep, we're done for today.
And then I'm just going to take the test tonight later.